and session 9. Today I'm going to introduce a person who is having experience more than 15 years and his paper publications more than 12 in international journals and having 5 patents, including 1 international design grant. And his best achievements, he awarded with best paper awarded at International Conference on Semantics, Cybernetics and Informatics in the year 2010. And he won into top 10 at prestigious IT Olympia 2016 under professional category. He received Innovative Professor of the Year award from Home Minister of Telangana at ITAP 2019, Hyderabad. And he received Global Teacher Role Model Award from MVLA Trust, Mumbai on the occasion of World Teachers' Day celebration on October 5th, 2020. He received Yuva Acharya Award from Bharat Education Excellence Award on the occasion of Teachers' Day celebration on September 5th, 2021. And again, he received Dr. Sarvepalli Radhakrishna Best Teacher Award from SOLET on the occasion of Teachers' Day celebration. He received Young Scientist Award from Sahasra Research Foundation on 1st October 2023. And now he is serving as a head Department of Computer Science and Engineering and Officer in charge of Examinations, JNT UK, University College of Engineering, Narsaraopeta. He is none other than our speaker, Dr. Sivaram Krishna Sir T. So I would like to invite our speaker to speak few words about that gathering today.
First of all, congratulations to all of you. Why? Because you have enrolled into something that's making the world run into new trends and technologies, deep learning. Of course, machine learning and deep learning, these technologies are taking up everything. Whatever may be your research domain or whatever may be you're working on. So at the end of the day, it is like you have to add a little bit of that salt and pepper from machine learning. Otherwise, the work is not getting completed or it's not taking up any new direction. So even in my PhD also, I started up doing with cloud security, but ended up doing something cloud security with machine learning. But that's how the things are going on these days. So today I just want to discuss about how the cybersecurity field is affected with the emergence of artificial intelligence as a whole and deep learning, in fact, or with specific concern on deep learning. So, meer movies lo choose untaru kada, no animals are harmed in this shooting of this movie. Atlage, whenever we present something about cybersecurity, I am very much cautious because we will be speaking about cyber crimes or some harassment or creating something fake or something. So if you learn those things and apply somewhere and maybe if you just refer to my name, I will be behind the bars. So I am on the safer side. So I am presenting all these things for your enlightenment and education only. If you do it for any illegal purpose, you will be solely responsible. Don't drag me into that. So this is the brief agenda of today's presentation. So we'll be starting up with why this area is important, why we need to discuss about it. Then maybe we'll go through what cybersecurity is really into, what changed all these years of cybersecurity and all. And maybe then we'll get into how AI is evolved in cybersecurity, what it started with and where we are today and where it is going to take us in the future. Maybe then we'll get to the actual discussion, how deep learning is affecting cybersecurity. Then what is the difference between maybe deep learning and machine learning with respect to security solutions? And we'll discuss about few challenges what we come across while implementing deep learning solutions. And maybe finally we'll see how deep learning can be seen on the other side. Instead of securing, if it falls into the hands of wrong hands, what it can impact. Maybe you might have heard recently there is a conference that happened in Delhi. While addressing that conference, even Narendra Modi ji, he expressed his concerns about artificial intelligence tools falling into the hands of terrorists. So that much concern AI is creating with respect to cyber security. So we'll get into that. Then maybe in this process we'll see some hands-ons, how actually the attacks will be implemented, how we can counter them and all. Yeah, so as I said already, cyber security and maybe machine learning in fact as a whole, they are the two technologies which you cannot avoid if you are having any digital presence. Whether you are having you're just a normal mobile phone user, or maybe you are a technologist, you are developing solutions, whatever may be the role you are in, you have to be somewhere concerned about your security, cyber security. You need to know what are the threats that are going on, how to protect yourself. At the same time, you need to be aware of how machine learning is taking different directions, how to make best use of it and all. So if these two technologies are combined, machine learning plus cyber security, definitely that's a very good thing to take up, maybe to just learn, or maybe to take up as a research topic, or maybe to build a career on. So we'll get through that. Internet ఉందండి ఇక్కడ? I just forgot that. To be something boring, well, only I am speaking and you are listening. So that too post lunch. You had a very good trip in the morning, so definitely you will be sleepy and don't want to listen. So I want to make it interactive. Please take out your mobile phones. Either if you have a QR scanner, you can either scan it or go to that website called slido.com and enter that code. Hope everyone on it. Yeah, questions are not yet displayed. You just log in and wait for that. You should be seeing something called CyberSec in the age of intelligence. So if you get that, you just leave it there. We'll get back to the action later. So, as I said already, my area of expertise is cybersecurity. I am not that much into machine learning or deep learning. Of course, I know some insights, but don't expect me to cover why sigmoid function works like that or why ReLU activation function is good. Don't ask me such questions. I know how to use them. I know which function is useful at which location. Only that is my level, because as I said, my expertise is in cybersecurity. But without this slide, I cannot continue with the presentation. So because you are already into 5th day, hope you all know what is the difference between AI, ML and DL. So AI is the bigger domain which talks about anything that can automatically take a decision on its own without human intervention. Whether it be just in a simple if-else condition that automatically triggers, to a robot which functions on its own, everything is AI. But in that process, we have a subdomain called machine learning, where we'll be training the model with some certain amount of data. From that training, it takes some features to be considered. Then when we test it on real world, based on the features from the data, it can take a decision. Then deep learning, maybe that feature selection and everything is also automated. So automatically it can take its own features, and it can, what we can rather say, hyperparameters, and everything will be there. So it's more complex but more insightful and more fruitful in the terms of results. So almost all fancy AI things will be developed with DL only, deep learning only. So that's the basic difference. So whenever we use the term AI, it also implies that deep learning also. So don't take it that why he is speaking only on AI when the FDP is about deep learning. So they are interrelated. You all very well aware of it. Now maybe you take out your mobile phones. Just type which feature you think that makes AI, ML and DL different, or what is that most important feature in your perspective. There are lot many things these three technologies or these three domains are different in, even though they are connected. So what do you think is the most important aspect? Only one typing? So do you want multiple choice or something? Phone a friend? 50-50? Yeah, data, okay. Yeah, of course. In general AI or the basic version of AI, we don't focus much on the data, we focus on the situation. Whereas ML is something which requires a lot of data to train. Of course, adaptability. Learning, yes, of course. That's it. Only 3 answers. Maybe you just connect to that Wi-Fi, ma'am, A05. Extracting features, yes, we just discussed about it. So we are around more than 20 people here, so I am expecting at least 20 different answers. Data availability. Yeah, learning is of course which makes them different at the primary level. So in AI we don't look into that concept of learning. We only talk about heuristics, decision makings and all. Feature extraction, okay. So whereas in ML we have some basic level of learning that is happening. In deep learning it's more intense. You need more data, more learning happening and an automated feature extraction. So I expected another answer, maybe you are not into that direction yet. Human intervention. In AI, or the basic AI I am talking about, not ML and DL. In the basic AI, even though the machine can take a decision on its own, the human intervention is a lot. Because it don't have any learning involved in it, it can only do basic decisions. So it's up to the user or human to direct the data in such a way that it is understandable by the machine. A basic AI machine cannot take anything as an input. So starting from input until the decision comes, we need to intervene in a lot of aspects. But whereas in ML, data is there already, it's getting trained, but at the feature extraction level, probably a little bit of human touch is required for deciding which feature is giving the best accuracy or other evaluation metrics. We need to decide. Based on that, we need to implement the model. Whereas in deep learning, we don't need anything. Everything is taken up by the model itself. So the human intervention is the least in deep learning. That's what makes it the best suited for cybersecurity, in my opinion. So this is a latest Forbes magazine. In their edition, I just found this quote, and it's very much intriguing and fascinating, I'd rather say. So the real magic in the AI domain is happening in deep learning only. Why? Because you might have seen across these 5 days different applications. Any specific applications where we can use deep learning in? A domain of applications probably. In medical field? Or I'll generalize it to entire domain of maybe image classification or computer vision as a whole, where the input is video, audio or image. For taking decisions we can use. Anything else? NLP, text processing. So if you want to take a decision based on the text or some written document, there we can use deep learning and so on. So almost if you identify any machine learning or AI application which is crazy, which you think is accurate or doing best, that obviously is a deep learning application. So, but as I said, the discussion is about how we can apply that deep learning in cyber security. So again, I have a question. Now I want everyone to participate, because based on that I want to proceed. So on a scale of 1 to 5, at what level you are in cyber security? You don't know anything, then maybe select 1. If you are an expert in that, maybe select 5. Okay. Okay. Fourteen participants. So half of you are new to cybersecurity. Okay, there is a balance. That's it. We had everyone's opinion here. Okay, maybe roughly in this case, I need to go through the basics also then, because most of you selected 1 and 2, which means you are not aware of cybersecurity terms also. Can I take it like that? So that graph is pretty self-explanatory. We have a lot of technology evolution that's happening. Maybe we started with simple businesses which are running on their own. From there it evolved into internet access, highly connected systems. Then it evolved into a 24/7 connectivity. So best examples are our mobile phones. So most of you, I know, you don't turn off your data. It will be on always. That's what we mean by 24/7 connectivity. And finally, of course, the near future, or it's already there, they are coming up something like user experience applications. So specific to the user, the application is going to customize itself. Can you give me an example for that? Experience-based applications or experience-driven applications. Maybe the simplest example is YouTube. No two people will have the same video recommendations when you open YouTube, right? Why? Because it's all dependent on what's your past history, which videos you liked, which videos you showed interest in, and so on. So based on the interest and experience of the user, the content is going to change, or it's getting changed. So that's what the era we are in. At the same time, along with the evaluation of the technology, there is an increasing cyber threats also. So how many of you think that maybe you are completely safe with respect to the technology you are using? No one? If you want to be safe, completely safe, there is only one option. You are not supposed to use any of the electronic gadgets. Any. Not even a basic version of phone. Then only in these days we can say we are 100% safe. Otherwise there are multiple threats that are coming up in different directions. We are going to see that anyway. So cybersecurity is something which need to be upgraded on a day-to-day basis. Otherwise you will be in a serious danger. So what dangers would we might face? Maximum ఏమవచ్చండి, అకౌంట్లోంచి డబ్బులు పోతాయి అంతేనా? Yeah, deepfakes, cyberbullying, yes. Anything else which affects your psychological and other aspects? ID thefts, yes. Even though you are not doing anything, you don't have any social media accounts, but someone else can create your an account and claiming it to be you, and they will do all that nonsense on Instagram or Facebook, and that automatically reflects on your reputation. Unfortunately, you did nothing. Even అంత లెవెల్ వరకు కూడా వెళ్ళనవసరం లేదండి. ఇఫ్ యూ వాంట్ టు స్పై ఆన్ సమ్వన్, ఇన్ ఎర్లియర్ డేస్ మనకు మూవీస్లో అది చూపించేవారు కదండి, మేబీ విలన్ మీద హీరో ఏదో స్పై చేయాలంటే హీ గోస్ దేర్, వాళ్ళ ఇంటి చుట్టూ 4 రౌండ్స్ వేసి అదంతా అబ్జర్వ్ చేసి ఇవన్నీ చేయాలి. బట్ నౌ డేస్ ఇట్స్ నాట్ రిక్వైర్డ్. You just need to know their name, legal name, that's enough. You have their maybe photos and everything available on Instagram, where they are going, how they are coming, all those details are available. Why we need to physically go to somewhere and spy on someone? You just need a computer with internet connection, that's enough. Anyway, there are a lot of threats. If we start covering up all those things, not just this session, not just these 5 days are enough to discuss all those things. Maybe I'll briefly explain the top 10 threats what we face on the cyber domain. So the first one is, of course, something called a ransomware. Any idea what a ransomware is? Sir? Yeah, it's of course a malware, but for a purpose I have differentiated that malware. Yes, they demand a ransom. Just like you kidnap someone, demand ransom from their family or company. In the same way, they kidnap something and demand money online. So what they can kidnap online? The simple thing is, it's a kind of like, for those who don't know even what malware is, you take it as a virus. It's a kind of virus or computer virus. If it is installed on your computer, immediately all the files and all the data will be locked. You won't be able to access anything. Imagine that happens to your laptop or mobile phone just now. Immediately. You don't know that it's going to happen. So what will be your life if it happens on your mobile phone right now? We don't have access to our contacts. ఎన్ని కాంటాక్ట్స్ మీకు గుర్తున్నాయండి? అట్లీస్ట్ ఇదివరకు రోజుల్లో అయితే మేబీ బేసిక్ ఫోన్స్ ఉన్నప్పుడు అట్లీస్ట్ ఒక 5-6 కాంటాక్ట్స్ అయినా గుర్తుండేవి. నౌ దట్ ఈస్ అన్ఫార్చునేట్లీ రెడ్యూస్ టు 0. ఆర్ అట్లీస్ట్ మేబీ మీకు ఫ్రీక్వెంట్గా కాల్ చేస్తారు, కాంటాక్ట్ లిస్ట్లో లేకపోతే కొంచెం. యువర్ ఫొటోస్, యువర్ బ్యాంక్ అకౌంట్ డీటెయిల్స్, your credit cards, your payments, so all the thing is stored in one place and that is locked up. For releasing it, they demand money. That's why it's called ransomware. So ఎట్లా పే చేయాలండి? ఒక బ్లాక్ బ్యాగ్లో ప్యాక్ చేసుకుని పట్టుకెళ్ళి డస్ట్బిన్లో పడేయాలా సినిమాలో చూపించినట్టు? దే యూజువల్లీ ఎక్స్పెక్ట్ ఇట్ ఇన్ ద ఫార్మ్ ఆఫ్ బిట్ కాయిన్స్, క్రిప్టో కరెన్సీస్. వై? బికాజ్ ఇఫ్ దే ఆస్క్ టు మేబీ నాకు ఈ నెంబర్కి ఫోన్పే చేయండి అన్నారు అనుకోండి, మీరు ఆ నెంబర్ పట్టుకెళ్ళి పోలీసులకి ఇస్తే ఈవెన్ బ్యాంక్ అకౌంట్ నెంబర్ ఆల్సో క్యాన్ బి ట్రేస్డ్. సో దట్స్ వై దే చూస్ అన్ట్రేసబుల్ అకౌంట్స్ ఆఫ్ క్రిప్టో కరెన్సీస్. వాటికి అకౌంట్ నెంబర్స్ అట్లాంటివి ఏమి ఉండవండి, అదొక లెంతీ కోడ్ ఉంటుంది, ఆ కోడ్కి పంపిస్తాం. క్రిప్టో కరెన్సీ అకౌంట్ ఓపెన్ చేయడానికి మీకు కేవైసీ, ఆధార్ కార్డ్ సబ్మిట్ చేయడం ఏమి ఉండవు. సో అకౌంట్ ఎవరిదో కూడా మనం ట్రేస్ చేయలేం. సో ఇట్స్ కంప్లీట్లీ anonymous. So they will go untraced. If it is okay, if it happens with a person, worst case లో ఆ డేటా అంతా మళ్ళీ పూలప్ చేసుకుంటా ఉంది. జనరల్గా మనకు ఫోన్స్ లేదంటే ల్యాప్టాప్స్ కరప్ట్ అయిపోయి కూడా ఒక్కొక్కసారి డేటా పోవచ్చు కదా. వీ కెనాట్ ప్రెడిక్ట్ దోస్ థింగ్స్. సో అట్లాగే డేటా పోయింది అనుకుని వీల్ లీవ్ ఇట్. వాట్ ఇఫ్ ఇట్ హ్యాపన్స్ విత్ అన్ ఆర్గనైజేషన్? I think maybe 1 or 1.5 years back, ransomware attack happened on AIMS, All India Medical Sciences, New Delhi. Their entire database and services were locked by an unknown hacker. They were unable to issue OP slips. People from across India go to AIMS to get cured for some serious diseases. If there is no cure in any of the advanced hospitals around, they'll ultimately look for AIMS. So with those kind of illnesses, they went to AIMS, and AIMS people were unable to retrieve their medical records because everything is locked. For several months, people waited on roads for that data to be released and their medical investigations continue. That's the serious effect ransomwares have on organizations. And maybe I think around 2 years back or 3 years back, I can't name the company, one of India's popular petroleum dealer, they got their entire system infected with a ransomware. Petroleum dealer ke affect aithe em avutundi, I mean petroleum supplier, I'd rather say, like HP, not HP. So their entire petroleum related transactions, from where they are importing, from whom they are importing, how much they paid, how much to be paid, to what suppliers in which states they sent this petrol, diesel and natural gas, how much dues are there, all this data is there and it is unfortunately locked up. Their entire business is standstill for several days. ఏం చేయాలి మరి అట్లాంటి కేసెస్లో? What we can do? Unfortunately, it's already locked. Yeah, if you have a backup, that's one thing. But usually these ransomwares are carefully crafted such that they will even infect the backups. Everything that is connected to your network. We'll get to that anyway, what we can do. Malware is, of course, ransomware is also a malware. Apart from that, all other softwares which do bad things, like computer viruses. Computer virus means some program which does something bad on your computer. It could be anything, including ransomware. Or maybe Trojans. Anyone heard of Trojans? So it looks like something genuine, maybe like a Word document. When you open it, it executes a computer virus. Spywares, one of the most prominent and dangerous form. They will be installed and running in the background. You don't know that they are there. They'll track all your activities. Especially on mobiles, these spywares are very much prominent these days. If that application is installed on your phone, whatever you do on your phone is sent to someone else. What do we do on phone? We call someone, so all your contacts are sent to someone else. We speak on phone, all those call recordings are sent. We type something, search something, those details are sent. We take pictures, those are also sent. Even if you don't do anything, there is a camera, microphone, which records all your day-to-day activities. So that much dangerous spywares are. Anyway, those are the second most intriguing threats what digital world is facing these days. Then we have social engineering. As I said, to get to know about someone, you don't need any of physical means these days. Just by observing their social network patterns, we get a lot of data about them. For example, if you want to attack someone online, if you want to hack into someone's computer, so what OS they are using, what computer they are using, what internet connectivity they are using, maybe that kind of information is necessary, and we can get it from their social media accounts. How come? Maybe one day you brought a new tablet or laptop, you take a selfie with it and post it online. That's it. I get to know what laptop you are using or mobile you are using. Then maybe one day you will be posting something about a billing issue with your internet provider. That gives me what provider you are handling at your home. So all the data can be easily got out. So that's what we mean by social engineering. Then threats again is data. Maybe data leaks, data thefts. Data leaks means someone without your permission takes your data, posts it online. Again, when we are dealing with individuals, of course it is serious, but think of an organization. I think in 2014 to 16, in that period, I don't remember the exact year, Yahoo faced one of the serious data breaches. Anybody using Yahoo still? Yahoo Mail? Not the students though, maybe some of the faculty members might be at least had a Yahoo Mail in the past. So all those email IDs, passwords and other sensitive information is leaked and it's sold on the web. So that immediately turned down the reputation of Yahoo a lot. Almost Yahoo is like at the verge of closing these days because of that leak. For example, you're a hospital where famous celebrities are also getting treated. What if all your data is copied and sold on web, or it's published on web? All your patient details, how much fees you have collected from them, what diseases they have, when they came in, which doctor treated them, what medicines were given, all that information is available on the web. Obviously, next day you don't see any patients there. Everybody will be in the fear that these guys are not good. So that will be the impact what we have on organization's reputation if data is leaked or theft. Next level we have something on availability. I don't want to get into the technicalities of it. For example, you are running a website. If someone takes it down, your website is not online. By some means, they have multiple ways of doing it. That's what we call denial of service. A simple thing could be, if I block your internet connection, you won't be able to provide service to your customers through that website. That's a simple example of DOS. And another serious threat that is evolving these days, misinformation or fake news. So maybe around some 5-6 years back, if you get something on WhatsApp, there is a possibility that it's either true or fake. But these days, if you are getting something on WhatsApp, maybe 99% it's fake. Every day we will be receiving lots of forwarded messages where the information is 100% fabricated. So you don't need to be a technologist or knowing technology to design such things. With a simple mobile phone in your hand, you can spread such rumors. And finally, something called supply chain attacks, not related to individuals though. If you are an organization, hope you might be knowing what supply chain means. If you own a factory, you will be taking indents, or we will accept demand from the customers. We produce goods, we deliver it to the customers. They use the goods, again there will be a request for new goods, and that cycle repeats. This is broadly what we call supply chain, and these days attackers are able to manipulate that thing also. For example, a customer requested for, assume that you are a car manufacturer, a showroom in Vizag requested for 10 new cars. What if it is manipulated to 100? Instead of 10, you manufactured 100 and sent to Vizag showroom. And they simply denied, saying that we only asked for 10. What about the remaining 90? That impacts your business. What about the reverse? You are a mobile phone manufacturer. There is a indent for 10,000 new mobiles from Visakhapatnam region. Someone manipulated it to 100. You thought only 100 phones are required and sent. There is a demand for 10,000 and you sent only 100. That creates a bad reputation for you in the market, saying that those people were unable to supply the goods and all, and again impacts your business. So such things are also happening these days. These are not my words. These are taken up from a very popular survey which identified these as top 10 threats, starting from 1. Of course 10 levandi. I have excluded some because they are too technical. But anyway, the top 1 is ransomware. Yeah, this is how a ransomware usually looks like. Hope you might have heard of this ransomware's name somewhere in news. WannaCry. Immediately after that COVID first wave, most of the hospitals in Europe were affected by this ransomware. They are facing a serious medical challenge and their data is locked up. So whenever you try to open something on your computer, you will see something like this. Your data is locked. So to release it, you have to pay. Where is that amount? Of course, this is the time left. It's $300. For one computer, you have to send or you have to pay $300. Then only they will release your data. Another threat is there. This rate is only for the next 2 days. After that, they will increase. And after 6 days, your data is permanently locked. You won't be able to get it back. For example, someone locks up your home and leaves. వేరే బయట వాళ్ళు వచ్చి మీ ఇంటికి తాళం వేసి వెళ్ళిపోయారండి, ఎలా ఓపెన్ చేస్తాం? We break the lock if the lock can be broken. What if the lock is so strong that without a key you cannot get in 100%? Then your only option is begging that guy to give your key back. Maybe that guy is now demanding $300, or let us assume it as how much it is? Around maybe multiplied by 80 or 90 these days. Or let's convert it to maybe 1,000 rupees. Of course it's huge, yeah. Okay, maybe let's fix it at 25,000. So that guy is asking, give me 25,000, then I will give you a key. If that guy is right before you, maybe you can just give the money and snatch the key. That guy is not in your presence, he is somewhere around. You need to send the money online, then he will send you back the key. Now the chances, maybe after accepting 25,000 also, he may give the key or may not. Again, according to another survey, so only 16% of the people got their data back normally. Their business is back to normal. If ransomware is infected for maybe 1,000 people, out of that maybe 100 people paid ransom, paid this $300. In those 100 people, only 16 people got their data back and their business is normal now. Around 40% of the people, they were unable to retrieve the data completely. Maybe because people started demanding more money to give the key. Or maybe partially your data is released. Assume that you have 1,000 files in your computer, maybe only 100 are released, still remaining 900 are locked. For that, they are demanding more money. Such kind of situations are there. In the rest 44% cases, they have given you the key, your data is released, but unfortunately all the data is also sold in the web. Your computer is unlocked. You could be able to access all your files, but all your data is copied and sold on the web. Even though your data is available with you, unfortunately you are facing a serious threat. Everybody is having access to your data online. Have you heard of this something called dark web? It's not the regular internet what we are using. There is a parallel internet whose access is not known to everybody, but that is used for all the illegal activities, especially for drug trading, weapon trading, and all these kind of illegal activities, selling data or accepting ransom in bitcoins. All those things happen on dark web. So not so popular and not having access to everybody. So it's like you are allowing a criminal to enter into your home and live with you. You cannot live your normal life back. So that's the problem what we face with ransomware. So what we are supposed to do here? let's not talk about technicalities. At any cost, I have to stop that ransomware from locking my computer. So please remember that point. We'll be back. So this is just some popular ransomwares and how they demanded from each. This is the first ransomware known as the AIDS Trojan, where way back in 1989 itself, even internet was not so popular. In that time, there happened to be a conference on HIV. Around 20,000 attendees participated from medical field. One smart guy, he distributed free floppy drives. For those who don't know what a floppy is, it's like a pen drive. How we have pen drive these days, in earlier days we have magnetic disks called floppies. So they installed a virus in that, disguising that to be some crucial information regarding that HIV disease. They distributed it to all 20,000 people. You got a free pen drive. What do? Immediately we try to plug into your computer and check what is there. So that's what most of those 20,000 people did, and all their computers were locked up. To release, he demanded $189, which is of course quite less, but that's in 1989. And to the recent, see this, there is this something called dark side ransomware. It is estimated that they got $4.4 billion US from that. I think that career is quite interesting, right? Instead of all these jobs and all, let us create a ransomware, release it to the public, and live your life happily. And of course, this NotPetya is another popular virus. It's mostly affected Ukrainian digital infrastructures. So hopefully it might be designed by Russian people. Because in 2017 also, Ukraine-Russia dispute is there, and it's getting heated up from there. Anyway. So this is all the present. So present enta bhayankaranga unte, imagine future. It's as bad as a pre-climax scene in Boypati's movie. Everything dark, everybody killing everyone, all blood and all. So it's as bad as that. So of course we'll be having that supply chain still there. It's a very big threat for companies. So this what we are talking about, advanced disinformation campaigns. So you are getting fake news in such a way that maybe even that genuine authority who is working in that company don't know whether it is genuine or fake. So that much accuracy and quality of fake news they are manufacturing. So the best example, as you mentioned, deep fakes. So we'll get to that anyway. We have a few discussions on that. Digital surveillance, and of course, authoritarianism and loss of privacy. Whenever you go to any store, any supermarket these days, before even billing your goods, the first thing what they ask for is, what is your phone number? Yes. Without phone number, that system don't even start. Why they require our phone numbers? They sell it to all the marketing agencies. Every day you will be attending maybe 20 to 30 marketing calls which are not required for you. So we don't have any privacy at all. Sometimes they ask you for Aadhaar card. You cannot deny. They are authoritatively they are taking up your data. And of course, because of these things, there is a spying happening on everyone. For example, if government want to spy on me, they don't need to do all these fancy things called phone tapping and all. If they just have my Aadhaar card, that's enough for them. Because it's linked with my mobile, they don't know they know what mobile phones I am using. It's linked with my bank accounts, they know my financial transactions. Whenever you check into a hotel, or whenever you want to board an aeroplane, you have to show your Aadhaar card. So they know all my travels and other details. That's it. So that's the biggest threat what we are already facing, but it's going to be even bad. Human error exploitation, of course it is again there. For example, whenever you are visiting any website, suddenly a pop-up comes. Before we even respond, there will be a timer running. Do you want to allow? Not now. That allow is usually highlighted and readily available, and it's usually big. So most of the times, without our intention or without our knowledge, you will be clicking on that allow. Obviously, they will be installing something on your computer, or they are taking up some of your data for malicious purposes. So that small human error is exploited by the attackers. Targeted attacks. So just like the viruses or some things, you don't need to design something specific for a big lot of people. Maybe if I want to attack one person in this class, maybe I'll take their personal information from social media, I'll get all that information, and I'll create an attack such that they don't know it's targeted to them. For example, sometimes we'll get a call saying that, hello, are you using SBI credit card? Yes, I am. Your card is blocked. To release it, there will be an OTP coming up. Please tell it to me. So how targeted it is? Why? Because how do that guy knows that I am using SBI credit card? So these kind of attacks are happening. Maybe you can expect those people to tell your name and other things also. That much targeted attacks are these days, because without that we don't believe, right? సడన్గా మీకు ఎవరో ఫోన్ చేసి మీకు ఓటీపీ వస్తుంది చెప్పండి అంటే మనం చెప్తామండి. దే హ్యావ్ టు మేక్ అస్ బిలీవ్ దట్ దే ఆర్ ఫ్రమ్ ద బ్యాంక్. సో బ్యాంక్లో ఉండే ఇన్ఫర్మేషన్ అంతా వాళ్ళు మనకు చెప్పాలి. సో దట్ మచ్ టార్గెటెడ్ ద అటాక్స్ ఆర్ హ్యాపెనింగ్ దీస్ డేస్. Lack of analysis or control of space-based infrastructure. So this is one of the most dangerous attack that is increasing these days. For example, we have a lot of infrastructure on space controlled by ISRO. What if one of that is hacked or the control is taken away? The results we cannot predict. You can't do anything with that, because they are covering up the globe and they are taking every picture, or maybe they are gathering a lot of information from across the globe. Lot of our military infrastructure is also dependent on space these days. If that satellite is taken over by someone else who is not a good friend of India, definitely we cannot expect some good days to follow. Advanced hybrid threats. Hybrid, hope you all aware of, will mix multiple threats into one so that the damage will be high. Skill shortage, because the attackers are evolving. The people are not that aware of. Everybody started using technology these days, but not everybody is aware of the threats what are there. Even if you go to a remote place in India, you can find smartphones there. People are using internet and for 24/7, but they are not definitely aware of the threats what we are facing. So it is easy to intrigue them to do something and damage them. Cross-border services are very much popular these days, especially because of these new laws that are coming up. Like we have EDPR law in EU, which restricts companies to store the data only in European Union region. We have a similar law in India also, which restricts people to store Indian citizens' data within Indian borders. So with these kind of restrictions, this something called cross-border communications are improving, or that business is coming up. If you attack that cross-border communications, maybe I am an Indian-based company, my server is in India, I am offering some services to China. Directly I cannot offer. You hope you know all those restrictions that are there in China and all. So that goes through a cross-border service provider. If I attack that provider, my services won't be available in China anymore. So it's as easy as that. And of course, the AI abuse. Attacks that are powered by and the attacks that are happening on artificial intelligence systems. Of course, it's not a cyber attack, but hope you heard of a recent development. I think somewhere in Korea, there is a robot which packs boxes and places it on a conveyor belt. సడన్గా రోబో పనిచేయడం మానేసిందండి. then service provider and పిలిచారు. He started repairing it. So at a time, it thought that, or it misinterpreted that person who is repairing it as a carton of something, a box. So forcibly, it squeezed that guy and placed him on the conveyor belt. Unfortunately, that guy is no more. So if you take control of AI-based systems, that much damage you can do. We are hearing a lot about autonomous cars or self-driving cars. In India also there are a lot of cars these days. Yeah, maybe not completely driverless, but cars which are having what is that? Cruise control features. Hope you are aware of this brand called MG Hector, MG Aster. All those are having this self-driving feature. If you are on a highway, you don't need to drive the car. You just keep it in that cruise control mode and you can relax. It will take care of everything. What if I could able to do some malicious activity on that? I can easily drag you into an accident without actually touching you or without actually coming to your face. So that's what we mean by AI abuse. So in parallel, of course, cyber security is also evolving. So especially this is what we are into until yesterday. Entire cyber security is dependent on antiviruses or the basic antivirus or maybe a firewall. So those kind of basic devices. But that is not anymore sufficient. So currently there are artificial intelligence based cyber security mechanisms which uses machine learning and heuristics to counter threats. But we will see very soon, this is also not enough. What evolving or what is coming up is deep learning based cyber security solutions. So which we will see now. So let's go through how actually this artificial intelligence is evolved into cyber security. So again, we don't look at that whole threat mapping. I want to focus only on malwares, or again, for those who cannot understand, assume it as computer virus. So before we get into that, we need to understand few basic terms. First thing is something called signature. So anybody aware of this hashing? To be specific, I'm talking about cryptographic hash functions like SHA, MD5. So it's also called the fingerprint of a file or data. Why? Because whatever may be the size of the data, if you pass it to a hash function, it always produces a fixed length hash code. If data 1 is there, if its hash code is, let us say 78F32 maybe AC, if you slightly change this entire thing will change. So just like how we have a fingerprint, hash code is so unique for the data. For one data you will get one hash. So is the case with viruses. If a virus is there, if you dump it into a hash function, it gives you a small hash code. That is what we call, okay, no problem. So that's what we call signature here. Then we have something called heuristics. Any idea what heuristics is? So yeah, of course, it's a search technique. What it searches for or what it looks for. Or heuristic based search you might have gone through these days. In this particular scenario, we focus on parts of the maybe virus code. If you have a program, if you have an if loop or something, a condition like this, if date is equal to maybe 15/12/23, do something. If this is an important part in the virus, we look for this part inside the virus code. If this part is present, then it is a virus, we have to be careful. That's what we do in heuristic based virus search or malware search. Then we have something called sandboxing. Any idea what sandboxing is? It's something like, maybe take this example. You want to test your new atomic weapon. Directly we cannot test it on a war field, right? First we need to do it inside a closed and restricted environment so that the damage is controlled. In the same way, you have a file with you, you have an app. You are doubtful that it might be containing virus. If you install it directly on your laptop or mobile phone, the virus will start doing all those bad things. So what I should do? I have to test it inside a contained environment. So we create a virtual machine using maybe VirtualBox or VMware or any of that tool, and we let the virus execute, not on the actual machine but on a small virtual machine. We'll see what it is doing. If it is doing something bad, we stop it. That's what we call sandboxing. It's also almost the same, only thing is it's a full-scale virtual machine and it's a partial virtual machine. Let's not get into that because it's too technical. I need to switch from this to containers and other things. Then memory analysis we have, where again we'll let the virus execute and we'll check what kind of memory operations or operations on RAM it is doing. Based on that, we'll decide whether it is a virus or not. Similarly, we have exploit prevention. We let the virus execute. If it is trying to do something wrong, for example, if a virus is trying to encrypt execution techniques, whereas for these things, you need to execute the virus, run the virus and see what it is doing. So that's why these are runtime viruses. Whatever it is happened after the execution of the virus, what it is to be done, that is handled here. One thing is detection. How the virus entered into your system, what it has done, and all that recovery. Detection and response mean that. Identifying a virus is present. Maybe virus already execute అయిపోయిందండి, back end లో run అవుతుంది. You are unable to trace it till now. To identify the presence of a virus, we go with detection. After identifying a virus, what to do? Only deleting that virus is not alone sufficient because it might have done some damage already. How to do the damage control, that's what we do in response. What is this? What's forensics? Maybe you heard of this term, and if you are interested in this, crime scene investigation series or movies. There are a lot many forensics, starting from those are DNA forensics, biological forensics. There is this Central Forensic Science Laboratory in Hyderabad. Recently, I am fortunate enough to visit that. Then I am fascinated to see that there are so many branches of forensics are there. Narcotics, one forensic department is there. మీరు కొన్నిసార్లు టీవీస్లో అయితే చూస్తారు కదండి, మూవీ యాక్టర్ది ఎవరిదో బ్లడ్ శాంపుల్ తీసుకున్నారు, వాళ్ళు డ్రగ్స్ తీసుకున్నారా లేదా అని ఐడెంటిఫై చేయడానికని. దట్స్ ఎ నార్కోటిక్ ఫోరెన్సిక్ డిపార్ట్మెంట్. ఎక్కడైనా బాంబ్ ఎక్స్ప్లోడ్ అయింది, సో ఆ బాంబ్ ఎక్కడ తయారైంది, అందులో ఏ కెమికల్ కాంపౌండ్స్ ఉన్నాయి, సో ఇదంతా ఐడెంటిఫై చేయడం. దేర్ ఇస్ ఎక్స్ప్లోజివ్ ఫోరెన్సిక్స్. ఒక డాక్యుమెంట్ వచ్చిందండి, అది జెన్యూనా కాదా, అక్కడ సైన్ చేసిన చెప్తున్న పర్సన్ నిజంగా సైన్ చేశాడా, ఫోర్జరీడ్ సైనా, డాక్యుమెంట్ ఫోరెన్సిక్స్. అండ్ వీ డూ హ్యావ్ డిజిటల్ ఫోరెన్సిక్స్. If a cyber crime is happened, collecting the evidence about the crime is what we call digital forensics, which is a very big area which have multiple subdomains and which is again a challenging task. ఎందుకంటే కంప్యూటర్స్లో కాపీ పేస్ట్ చాలా ఈజీ అండి, లేదంటే డిలీట్ చేయడం చాలా ఈజీ. వాట్ ఇఫ్ ద ఎవిడెన్స్ ఈస్ డిలీటెడ్ బై సమ్వన్, హౌ టు రికవర్ ఇట్ బ్యాక్. సో ఆల్ సచ్ థింగ్స్ కమ్స్ దేర్. ఎనీవే, హియర్ forensics means you have already identified that there is a virus in your computer. Who developed it, how it is installed in your computer, gathering that evidence is what we call forensics here. Okay, ma'am. So we'll continue after 10 minutes. So having seen the basics about what we need for threat prevention in computers. So let us see how actually this threat prevention strategies, what we are seeing today, are evolved. So around in 1980s, the first computer, again, because not everybody is comfortable, I'll use the term virus. So when the first computer virus was introduced, people were literally in a panic. Hope you guys know about ARPANET, the predecessor of the internet. So that's when the initial computer virus was designed, which actually displayed a small message like creeper, catch me if you can. That's the only damage that could able to do. But that seriously alerted the people who are working on that ARPANET, because it involves advanced research and military facilities connected to it. So they started coming up with the idea of designing an antivirus. So to be specific, I think it's in the year 1985, as per some sources, and some people say that it's 87, but somewhere around that time, the first antivirus was designed. And from then till date, most of the antiviruses use this technology called signature-based virus detection, which again means this: whenever a file is copied into a computer, that is given as input to a hash function, and a hash code is generated. Every antivirus will have a list of hash codes or signatures. So there will be a list of signatures which belong to viruses. We'll just make a comparison. If this hash code is in the list of signatures, then that file is a virus. A simple searching mechanism, that's it. That's why most of the antiviruses asks you to update their signatures for every couple of days. చూసే ఉంటారు కదండి, యాంటీవైరస్ మీరు అప్డేట్ చేయలేదనుకోండి, ఇట్ కీప్ ఆన్ పాపింగ్ అలర్ట్స్, యువర్ యాంటీవైరస్ ఈజ్ అవుట్ ఆఫ్ డేట్. That's the reason. They will update with latest signatures. So that's the initial era of antiviruses, where 98% of the viruses they could able to prevent with this basic antivirus. Only 2% got through. In the next level, what happened is, in cybersecurity it is always that cat and mouse game, where this so-called attackers or virus designers, they came up with the idea called polymorphic code, which means that the executable code of the virus is going to change on its own. Nobody need to manually change it. In one computer, if it is having, let us say, the code XYZ, on another computer, the instructions will be replaced with something else. As we are aware of programming languages, we can do the same task in multiple ways. Maybe in some case you have a for loop, replace it with a while loop. Maybe somewhere else replace it with a do while loop. What happens is, if the data changes, signature also changes. If the code changes, virus signature also changes. Even though the same virus you are searching for, its signature is changed now. Because of that introduction of polymorphic codes, only 60% of the viruses were caught using signature-based or traditional antiviruses. Around 40% got through. So the threat got bigger. So that's a serious concern. So cybersecurity experts, they came up with this idea called heuristic-based antiviruses. Now what they did is, instead of searching for the entire virus as a whole, the code of the virus is divided into multiple blocks or heuristics. Even if some part of the code is changed, remaining things are still there. Using that statistics, we try to identify whether it is a virus or not. That's what we mean by heuristic-based antiviruses. So by this time, only 12% were signature-based identifications, but around 80% of the viruses were detected in this heuristic-based detection. Only 8% got through the antivirus at this stage. This is around 1990s, the early 1990s. Again, the cat and mouse game into the next level. Because there is a counter by cybersecurity experts, virus designers, they came with the idea of encrypted payloads. If virus code is visible to the antivirus, then it can do something. What if the code is hidden inside a layer of security? For example, in airports and railway stations, we will be seeing these bag scanners. Explosives లేదంటే ఏదైనా dangerous material ఎవరన్నా పట్టుకెళ్తున్నారా అని ఐడెంటిఫై చేయడానికండి. If you can see through that bag, through that X-ray scanner, you can identify whether bomb is there or not, something. If you design a bag such that it disuses that X-ray scanner, it only shows clothes and other normal things, even though there is an explosive inside. Can we stop it with that bag scanner, X-ray based bag scanner? No. That's what they came up with. Encrypted payloads. They encrypted entire virus code. For those who don't know what is encryption, simply we convert the basic data into a scrambled format. With only certain operations, we can get it back. So your entire data is looking as some junk. We cannot see what is there inside it. So obviously, these antiviruses failed, and 35% of the threats got through the antiviruses. Now we need something else to stop this. Until now, these methods, what we call preventive threat detections. Why? Because whenever a file is copied, we are scanning it and we are deciding whether it is virus or not. If it is a virus, we'll stop it from execution. If it is not a virus, let it through. So in the next level, we have something called sandboxing, what we discussed. Unfortunately, you cannot see the virus code now. It's hidden inside a shield. So what we are doing now is, okay, let it execute. If it is doing something wrong, then let us stop it. But it's as bad as trying to see whether something is a bomb or not by lighting it. Definitely, we have to be on the safer side. So instead of executing it directly, we keep it inside a virtualized environment and see what it is doing. That is what we call sandboxing solutions. So we start with signature. If it fails, go through heuristics. If it fails, execute the virus in a contained environment and see the results. If it is all good, then only release it. Otherwise, block it. So you are executing and stopping it. So these are called reactionary preventive methods. Because you are letting the virus execute, then you are responding. So in this case, as a whole, we could able to stop around 95% of the threats with sandboxing. Why? Because you are letting the virus execute. So you can clearly identify whether it is a virus or not. Only 5% of the threats got through at this level. In the next stage, again, virus developers came up with another idea called anti-sandbox techniques or exploits. The simple idea is, whenever you are copying a file, execute and see the result. Now, they have added a timer before execution. When you click on the file, it's not going to execute. It waits for certain time. So at this stage, what this antiviruses or sandboxes thought is, it's not a virus. It is something simply not doing anything. It's a genuine file, so let it leave. But unfortunately, after that time limit is over, it's going to blast up. It's going to execute that virus payload. So 50% of the threats got through at this level. This is a very serious concern. So pre-execution, we are checking the heuristics first, signature first, then heuristics. If it got through both the levels, then you are allowing it to execute in a contained environment, but unfortunately, there it's not doing the bad thing. It knows that it is in a sandbox and waiting. మీరు దాన్ని కంటైన్డ్ ఎన్విరాన్మెంట్ నుంచి బయటికి దిగానే దెన్ ఇట్ ఎక్స్ప్లోడ్స్. సో దట్ ఈస్ ద అడ్వాంటేజ్ ఆర్ అడ్వాన్స్మెంట్ ద వైరస్ క్రియేటర్స్ got through, and because of that there is a 50% breach ratio. So to counter that, cyber security experts came up with behavioral analysis. So it's a very simple idea. You executed it in a contained environment. Unfortunately, you are unable to identify it. So let it execute it on the PC at the next level. See, the basic problem is, if you stop everything, what happens? I put on a restriction on your mobile phone such that you will never going to, I am never going to allow you to install any app. Is that okay? Definitely not. We need to install certain applications on the mobile phone. That's why we are purchasing these smartphones. But if you install apps, there could be viruses also in that. So we tried to contain them in a sandbox and test till now. It failed. Now what we are doing is, okay, let it execute. Assume that it's not an attack. So let it execute it on the mobile or laptop. After installation, if something happens, or if it is trying to do something, then block it. So that's why it is called behavioral analysis. Based on the behavior of the executable file, we'll decide whether to allow it or block it. So because of it again, there are 95% threats that were blocked, only 5% got through. So this is a kind of AI, we can rather say. Why? Because if you observe here, what we are doing here is, you are allowing the file to run and you are trying to analyze its behavior. With normal applications, we cannot do that. So a certain level of AI is already here. And in the next level, again, attackers improved themselves with something called new attack vectors. What you are doing, if there is certain behavior, you are stopping it as a virus. So we change the behavior frequently. For example, if a virus, if a file is maybe waiting for 15 seconds before execution, it could be a virus. That's your presumption. Now I don't wait for 15 seconds. I'll wait only for 5 seconds. Or I'll wait for 25 seconds. The behavior is changed. So this behavior analysis based prevention mechanism can't identify. So because of this, 25% of the threats were through. A behavioral analysis is like simple thing, ma'am. For example, you are a police officer. People are there in a crowd. Usually, police suspects few people, assuming that they are criminals. What is the base for them? Based on their behavior, maybe suspicious looks, or maybe trying to avoid police when walking through. So all these things unwantedly. So all these kind of things will have a checklist. If a file is in that checklist, we assume it as a virus. Otherwise, we will let it through. So because there are new attack vectors, a new method of countering them is required. So that's where the pure AI in the form of machine learning entered here. So ML is here now. So it's same as before. It's behavioral analysis only, but a machine learning based. So whenever we talk about ML, we require a data set to train the model. So whatever is the antivirus developer, they will train the antivirus before installing on a, before releasing with a maybe virus data set. It will be having multiple features. Based on that, the training will be done. So whenever it is installed, whenever a new file is there, so this next gen antivirus, usually called NGAV, this next gen antivirus will perform a static analysis to identify whether it is virus or not. So in this case, fortunately, 90% of the threats were prevented. So altogether, there is a 98% prevention, so only 2% of the threats got through. So it's a big breakthrough. Why? Because now the job is given to a machine learning model which is well trained using the data. So is there anything wrong here or in this approach? Or assume you are that so-called virus designer. I want to fool this. So what can we do? You want to fool a machine learning model. So what we can do? So you need to give input such that it won't fit into the model it is trained in. That's it. So that's the next level, called the metamorphic codes. And there is also this thing called fileless viruses evolved. Till now, our assumption is that when you are downloading a file or when you are installing a file, either it is a virus or a normal file. Now they are mixed up. Instead of creating virus as a separate file, viruses started hiding themselves inside other files, like maybe in Word documents, Excel files, or maybe inside software updates. So your virus is still there, but it's not a complete file now. It's hidden inside another genuine file. So identifying them with normal machine learning algorithms failed here. So we require something else. And here there is something called threat hunting started, or also known as EDR, endpoint detect and respond mechanism. What happens here is, we'll try to do the behavioral analysis first. If it fails, we'll go check with ML based or next gen antivirus. Still, if it fails, we'll let it run. If it is a virus, then we'll update the model. You're running using a machine learning model. So if something fools the model, something you have taken an input which don't fit into the model, obviously what we are supposed to do, train the model with the new input. So that's what we mean by threat hunting here. The virus is already installed, damage is done. So we cannot get back the damage what is caused. But what we can improve using is, we'll train the model with that new threat. So if the same threat comes into another computer, we can identify. The antivirus improved itself. So in the next level, or in the final era, what we are looking at today and which is going to be tomorrow's antivirus is deep learning based antiviruses. The advantage here is, you don't or it won't actually rely on the fixed set of training data. From the training data, it extracts the hyperparameters. From there, it does the feature selection and all on its own based on the best metrics, and the model is under execution. Whenever a new threat comes, automatically its hyperparameters are tuned such that it identifies that threat. So actually these antiviruses are not into popular market yet. There are only very few service providers available. One is something called Deep Instinct. This is not an endpoint protection. You cannot purchase one license and install it on your computer. This is an enterprise version. If you own a company, you can hire the services of Deep Instinct. At that level it is currently in. But maybe we can expect very soon we will be seeing antiviruses powered with deep learning. So the advantage here is, more than 99% threat prevention is possible with deep learning based antiviruses, or at least with Deep Instinct in fact. So the advantage what we have with deep learning is, one thing is of course enhanced detection possibilities. Why? Because of the nature of deep learning and the level of training that is involved with multiple layers and neural networks. So even though there is a new threat, it could easily adapt to that threat and identify. That's the biggest advantage what we have in deep learning. So in cyber security, we have something called zero-day exploits, which is a popular term. Which means attacks or viruses or something which is not popularly known to everybody. For example, I am using, let us say, Chrome browser. In Chrome browser, certain security lapse is there. If it is not openly known to everyone, people starts attacking on that, or attacker who knows that will start attacking on that particular loophole. So attacks are happening and we don't know that they are there. Those are called zero-day exploits. Usually countering them is very hard, but with deep learning it is quite simple, or easy we could rather say. So there is another aspect here I forgot to mention. If you observe here, there is a lot of machine learning, training and so on. So what happens with all this? especially people who already did machine learning knew it very well. For training the model, it takes a lot of time. So every time you need to do all that analysis and decide whether it is a virus or not. So for installing something, the virus takes a lot of time. Obviously, it slows down your computer's performance. I know most of the people are not happy with antivirus performance, because whenever you install an antivirus, computer slows down. The biggest reason is this: it do a lot of analysis. But we cannot take it out, because if you remove that protection, virus might come in. At the same time, because it is taking so much of time, meanwhile, if a virus executes and encrypts your files, your data is gone. Especially we have seen ransomwares. They usually execute in microseconds. This could usually take several seconds. So obviously, before the antivirus decides whether it is a virus or not, it already done the damage. Whereas in deep learning case, the response time is very quick when compared with the standard machine learning based. Why? Because we don't have these many levels of filtering. Only a model is there and it is identifying whether it is a virus or not. A pre-trained model. Training is already done. It just fine-tunes the parameters and decides whether it is a virus or not. So because of that quick response, we can use it for real-time threat analysis where actual attacks are happening. We can quickly counter them. So let's quickly get into in what areas of cybersecurity we can use this deep learning. So there are a lot actually. So this area we have already seen, malware analysis, deciding whether a particular program is malware or virus or not. There are actually two malware analysis domains, hardware based and software based, but we don't touch the hardware based yet because deep learning works or suits better for software based. In that again we have static and dynamic analysis. Static analysis means there will be a predefined pattern we just follow to decide whether it is a virus or not. Whereas in dynamic model, it evolves, it changes. So deep learning best suits for this software based dynamic malware analysis. Another aspect where it is good at is intrusion detection. Again, this is not for individual computers, this is usually for networks, organizations. Assume that you're working with a company and that company might usually face hacking attempts or intruder attempts. How to stop them? For that, again there are two things involved in intrusion detection. One is called intrusion detection, identifying that an attack is happening and stopping it. After that, identifying that, we need to classify it. We need to place it in some of the other classes of the intrusion detection. Why? Why we need to identify to which class it belongs? Maybe based on that, you can design your countermeasures. Next time when the same attack happens, we can easily stop it. And another level is something called situational awareness. For this particular region, actually there are no existing good mechanisms except deep learning. We are expecting that deep learning is going to take all these things. Why? Because all these areas of cybersecurity depend on the situation. From X to Y, the methodology completely changes. The best example is spam detection. In emails, we receive a lot of spam emails on day-to-day thing. But a lot of spam emails get through the filters, even on the sophisticated filters in Gmail also. అవును కదండి, అన్ని స్పామ్లోకి వెళ్ళట్లేదు కదా. Sometimes they are evading that spam filtering mechanisms. So how that is happening is, people are getting what we'd say smart, and they are designing emails such that some parts are hidden from the spam filters, some parts are websites. For example, you are trying to log in into SBI's website. What is the guarantee that it is from SBI? Sometimes fake website also looks exactly similar. In such cases, we can take the help of deep learning in identifying whether it is genuine or not. Similarly, log analysis. Every activity what you do on electronic devices, maybe if you make a call on your smartphone, it is stored on call logs. Similarly, you have message logs, internet logs, battery logs, a lot many logs are available. By analyzing those logs also, we can identify the presence of threats. As I said, background process if they are there, if spywares are there. So those things can be analyzed by looking at logs, and with deep learning we can do it better. So how can we identify whether our mobile phone is bugged? Yeah, the first and most important thing is heating up. Unnecessarily, you are not doing anything on the mobile. It's simply lying there, but still it is getting heated up means definitely something wrong. Anything else? Unwanted apps installed, unwanted maybe changes which you haven't done if they are happening. Unnecessarily, if your screen is lighting up and going dark. The phone is there, you are not doing anything. Suddenly, the screen got brightened up. There are no new notifications or anything, and immediately it went to normal, which means something is wrong and happening there. If the phone battery is draining fast, if phone is slowing down unnecessarily, all these are indications that your phone might be bugged. Maybe I'll focus on this thing, steganography. Anyone having idea about what is it? Steganography? Yeah, we can hide something inside, maybe image or audio or video. It could be a text or something. For example, you want to transmit something to your friend, and you have a doubt that someone in between might be looking at it. So the best way is hiding it. Hiding it inside another image or video. That's what we call steganography. So it's particularly important in certain areas called watermarking. For example, you're an artist. You designed a new digital painting. What if someone simply copy pastes it and claims it that they are the owners of the painting? So one simple way is, if there is a hidden watermark in it, you can retrieve the watermark and prove that it's your work, not theirs. So that's what steganography also deals with. It's a part of it. So maybe with deep learning we can develop better steganography techniques. Not so easy to fool and all. Behavioral analysis we just discussed. Whenever you are analyzing the pattern of a person or program or something, deep learning definitely helps better than the other technologies. So these are all the emerging and gray areas where deep learning could help. Solutions were not completely ready, still research is happening. So if you want to do research in this domain, definitely these are the gray areas. Of course they are not gray, they are blue, but those blue things are the areas where research is, with deep learning, is expected. Yeah, especially intrusion detection with the help of CNNs and RNNs. So it has 3 classes which are already under development. First is called next generation firewalls. A firewall usually scans all the network traffic that comes in and goes out. So next gen firewalls, with the help of CNNs and RNNs, they could do a better job in intrusion identification. Similarly, web application firewalls, instead of a network, if you are hosting a website or something, so what kind of requests that are coming for your application, what responses are going out, that we can control with web application firewalls. And user and entity behavioral analytics, this is again a latest development in cyber security, which is completely based on AI. So in this area also, deep learning is coming up now. So these are specific methods of how we can implement deep learning and all. Maybe for the sake of time, I'll skip this part because I also want to go quickly to hands-on. So, but the most important thing is, whenever you want to use deep learning, first thing and the foremost thing is categorization of your problem is the most important thing, because based on that categorization only we could able to identify what data is required for training. Based on that only we could able to identify which algorithm, deep learning algorithm is suitable for that. From that only we could able to identify which deep learning model is required to be implemented. If you have taken a good problem where deep learning is useful, maybe CNN is particularly useful there, and you have implemented it with RNNs, obviously the solution is not going to be good. So this particular path need to be taken carefully, then only we will get fruitful results. Again, let's not deep dive into that. Why? Because it depends on, or it changes from problem to problem. So each problem is a specific case, and it could be deeply to be studied. So we cannot generalize this aspect for all the cybersecurity problems. Because something which suits for spam, it may not suit for antivirus detection or the virus classification. So the thing is, we already have a lot of antiviruses, firewalls, spam filters, which are already developed with machine learning models. So why they are not enough? Why we require deep learning to be involved in that particular areas? So the first thing is, of course, in the case of unknown threats, if a new virus, new attack comes in, the machine learning model can identify that only after execution. We have already seen that. Especially in threat hunting, you first execute the virus and decide whether it is virus or not. But as I said, it's very dangerous. You have an object in your hand and you have a doubt that it could be a bomb. We cannot let it explode and decide if it is a bomb or not. It's of no use. Whereas in deep learning, we can do it pre-execution. We can prevent the execution if it is identified pre-execution. So that is especially because of the pattern identification in deep learning. Another important thing is the model training. So usually machine learning models are trained with 2% of data. What do we mean by that? Usually we take train test split as 80-20, right? That's the general assumption. But what do we mean by only 2% of data? In the entire available domain, for a machine learning model to be trained, a less than 2% data is enough. That's why usually the training data sets what we take are, most of the cases we go with text-based data, that too in smaller amounts. But whereas if you want to go for a deep learning approach, if you have implemented any deep learning models like MNIST dataset, they are in GBs and TBs. So that's the scale of data we train the model with. So obviously it's going to be a good solution because model training is so rigorous. Resilience to attacks or prevention of attacks. Yeah, so ML based models are more susceptible for AI attacks. So what AI attacks, maybe I'll save it for the next slides. We'll get back to that. Ability to prevent unknown threats is very low in ML attacks, but whereas it's very high in deep learning based. Whenever a new attack comes, it's easy to identify with deep learning. False positives means it's a genuine file, but it is classified as a virus. If more the false positives, more the inconvenience the user will be facing. He is trying to download and install a genuine file, and you classified it as a virus. That definitely not the user expects. So it's around 1 to 2% in ML based cybersecurity solutions, but it is only less than 0.1% in deep learning solutions. Coming to accuracy, we have seen around 50 to 70% accuracy of threat prevention is there in ML based, where it is more than 99% in deep learning based. So because of all these factors, we can strongly say that deep learning based cybersecurity solutions are very much required for the future of digital age. But it's not that easy, I think. Theoretically, it's a good movie. The script is okay. But for implementing it, we face a lot many challenges. Can you name few? If you are still on slide, or maybe you can just mention them. What do you think is the most challenging aspect we'll face with implementing deep learning for cybersecurity? If it is not working, you just tell me. What do you think is the most challenging aspect? Interpreting data, yes, of course, because deep learning requires huge amounts of data, as we just mentioned. Of course, deep learning, after training, it's very good, but for training itself, we require a lot of data. So gathering that specific data which is suitable for that application is challenging. Making? Yeah, identifying the correct model. Yes, of course. If you do it with the wrong model, obviously the results are not good. Fast extraction of malware, I think this is actually an advantage with the deep learning. Deep learning can quickly prevent malware execution, so it's not that bad. Feature extraction is also good in deep learning when compared with machine learning. So those two, I don't think they are the challenges, they are the benefits we have. Anything else? Yes, what I feel. First thing is, of course, data. The quality and quantity of data required for deep learning is very much high. If you train it with less data, or if you train it with more data which is not suitable for that problem, in both the cases deep learning fails miserably. For example, I think I need to stop this slideshow. So this is something called teachable machine, Google's machine learning experiment. So this is a best way of developing, without any coding knowledge, developing a pre-trained model and using it. So I just want to use image based machine here, standard model. Yeah, I think I need to switch on my webcam. Maybe I want to design a classifier which distinguish between water bottle and mic. Yeah. So I want to train the model for water bottle. So on multiple angles and directions I want to train the model. So water bottle data set is ready. Now I want to maybe I will rename the class. Class 1 is bottle. Class 2 is mic. So there are 74 samples for mic and 108 samples for water bottle. Let's train the model. So training the model is as simple as that. Oh, it's training for 50 epochs. Oh my god. Done. My model is ready. Let's test it. See, 100% it is identified as mic. in every direction. Good. It's bottle, very good. What's this? Is it a water bottle? And why it is classifying my hand as water bottle? Now see, it's mic. So that's the biggest problem what we face with even machine learning and deep learning. If you don't train in a particular aspect, if that situation arises, model don't know how to react. So that's the biggest challenge what we face with learning. Or let me see. So it's classified as mic now. Oh, nice. Another thing is, I have trained this entire thing with this poster in the background. What if that poster is not there? Let me check. See? That empty wall is classified as mic. Yes. That's the challenge what we need to face in case of ML based or DL based solutions. If something is not there in the data, how the model reacts is unpredictable. So we have multiple aspects with respect to bias and with respect to data augmentation and maybe missing values. There are many aspects in data which you need to carefully handle, without which the model may not work up to the expectations. Second thing is, usually whenever I go to any of these project external examinations, project viva voices, so most of the students these days come up with ML based or DL based solutions. Sir, we have taken this data set, trained the model, and the accuracy is this percentage. So the simple thing what I always ask is, for example, if you are taking, let us say, diabetes detection data set, which features your model is focusing more on? They don't know. It's not their fault. Their entire concept of training and learning is such that. Why? Because we usually call them those DL and ML models as black boxes. Sitting outside, we don't know what's happening inside. If we implement such things, especially in areas like medical classifications or diagnosis and maybe cybersecurity solutions, what is the guarantee that it is a genuine answer? Just now we have seen, if you are presenting an input, something it is not trained in that direction. In that case, it can behave something different. We can't predict the behavior. So you have typed some data, your own stats, and it is saying that 100% chances that you are having diabetes. What is the guarantee for that? Maybe my stats are not in the trained data, maybe hypothesis. So what should I do? How can I trust the answers that are given by a DL or ML model? That's always the biggest question. Another thing is attacks. Of course, we skipped it last time, but still, let us save it for the next slides. We are going to see what kind of attacks are possible on DL and ML models. Then overhead, we just discussed about it. Training a machine learning model is not that an easy job. It takes a lot of time. And training deep learning is even harder. So what is the craziest training time you have encountered? For training, maybe if you have implemented any ML or DL based model, how long it took for you? What's the longest time? 1 minute? 2 minutes? 1 hour? 10 hours? Yes, it's quite possible. And I have seen models which are trained for 4 to 5 days. They are so feature specific that the feature extraction took a lot of time. It took me around 5 days. Fortunately, it's on Google Colab, so I don't have to turn on my machine and wait for that. So it took 5 days one time. So just to train the model, you need to wait. So it requires a lot of CPU time, memory, power, heating up issues, all these need to be managed when you are developing a deep learning based solution. And the obvious thing is integration. There are already antiviruses, firewalls, everything is there. All of a sudden you are proposing deep learning, which means that I have to throw all the existing softwares and hardware in dump? Definitely not. There need to be ways which integrate the existing machines with the upcoming things, which is a gray area still. A lot of work need to be done in that direction. So, but in near future we can expect these solutions. Of course, for that black box issue, we have something called XAI that is coming up, explainable artificial intelligence, where a model's details, how a result is obtained, can be clearly seen. That transparency is introduced in XAI, where you can identify how a particular output is derived on a machine learning or deep learning model. If you have that, obviously we can trust the model because you know the process. Next thing is transfer learning and federated learning are greatly being worked on these days. Any idea what is transfer learning? Pre-trained models we are using. So learning is done on a different machine somewhere else. You are just using the model. In other words, that learning that happened somewhere else is transferred to your application. So because of those pre-trained models, a lot of work is being saved. At the same time, we have something called federated learning. The problem with normal machine learning models is sometimes we have to give sensitive data to them. For example, you might have come across this face attendance app these days. In Jnanabhoomi they have introduced. So everybody have to click their selfies for that attendance. My question is, isn't that a privacy issue? Because they can see in which clothes I am in, how I am looking today, what dress I am wearing, maybe my surroundings, all those things are getting leaked now. Assume a scenario. All your students and faculty in a college, they are giving their facial attendance, and that attendance is processed only within the college. And the summary is being sent to Jnanabhoomi. That's quite interesting and okay for me. Why? Because my data is not leaving the college. In the same way, if we are training a machine learning model at different places such that data is not augmented at one location, it contributes in two things. One thing, you are distributing the load. Another thing, their data is not taken up by someone else. Their data is there, training happened, only the essence of the training is summarized and the model is designed. That's what we call federated learning. So these two are the new and emerging technologies in ML and DL. If they are into grand reality, definitely we can expect a lot of appreciation for deep learning based cybersecurity. Because you don't need to consume, or what we can rather say, you don't need to spend a lot of resources, your CPU time, GPU time, heating up issues, electricity consumption, all those will not be there. Adversarial defense, I just mentioned that there are attacks possible on AI models and how to counter them. Then this thing called edge computing based cyber security solutions. Any idea what is edge computing? Cloud computing is summarizing everything and storing it in a location, a centralized server or something, a data center. Opposite to that, edge means we do all the processing at the basic level. These days we are having a lot many smart devices, smartphones, smart lights, smart TVs, smart fans, smart refrigerators, smart washing machines, whatnot. So everything is having a digital device in it. What if they are attacked? So the decision need to be taken at the edge level, not at a center. To be implemented at edge computing level. And most importantly, for implementing all such things, we require people who are good at cyber security and also good at deep learning and machine learning. So we require a lot of collaboration between these kind of research teams or development teams, which is again yet to happen. So this area we haven't yet touched. Let us see that. Oh. What happened? Okay. So let me show you a small video. Madam, audio కూడా ఎక్కడి నుంచి వస్తుందా? అసలు ఏం రావట్లేదండి. లేదండి, ప్రజెంటేషన్ ఆగింది. ఇక్కడ రన్ అవుతుంది, అక్కడ ఆగింది, చూడండి ఒకసారి. యా, ఓకే, ఫైన్. Audio is not coming up here. Anyway, maybe from that you can sense what's happening there. The former president of US, Obama, is addressing a press conference, or he is speaking to the nation. So his exact words are like something which we don't expect from him. He is praising the adversaries and he is calling Trump with all that foul language. So can we expect that? So what actually happened is this: that guy who spoke those words and mimicked it with the video of President Obama, or former President Obama. So people who have seen only the first part, what do they think? They think that Obama spoke such a bold word and he is not doing good. But actually what happened is something else. So this is the best example what this so-called advancement in AI, DL, ML and could do to the public. So the next part what we look at is attacks that are powered by deep learning and machine learning. So till now we have seen DL as a protector from attacks. Now it's on the other side. It's no more a hero, it's the villain now. So these are possible attacks what could happen with artificial intelligence or deep learning. So out of all this, first thing is automated attacks. Maybe I'll summarize these two at a time: automated attacks and automated malware detection. So what happens here is, so automatically a virus can change itself and pass through all those hurdles or sophistications what are there. A virus is now powered with artificial intelligence so that it can easily disguise the antivirus. So imagine the scale. Just now we have seen if it is on the protecting side, it's very good. What if it switches the sides? What if the attackers uses deep learning? Second thing, sophisticated phishing and social engineering. We just discussed that we can identify some potential sensitive information about people from their social network platforms. But for doing that you need to spend a lot of time. Instead of that, I'll create a AI based or deep learning based model which automatically extracts sensitive information about people around me and summarizes it up. If you just give it your Instagram ID to the model, it sees all your friends, gathers information about your friends, whatever it is sensitive, it summarizes and gives it to you. So that's the scale what we can expect. Evasion of detection mechanisms, as I just said. Using deep learning, we can bypass cyber security. And of course, most importantly, fake news, what we have just witnessed. We can create deep fakes. What's deep fake? Why it is called deep fake? It's a fake news which is created using deep learning. Deep learning is the heart of it. Why we are talking about deep fakes, not about any other things? What's so special about deep fakes? It is very hard to detect that it's a fake news. They are so, what we can say, appealing and compromising. It is very hard to detect original and fake. For example, what you have seen is the best example. Obama speaking something bad about Trump. That didn't happen actually. And recently I have seen a video where Prime Minister Modi is doing that Garba dance. He himself admitted that it's a fake video. So that's the world we are living in. What you are looking at it, you cannot trust. We don't know whether it is true or not. And of course, automated vulnerability discovery. You just run a machine, it automatically scans all the computers in a network and give you list of loopholes they are having so that you can plan an attack. Everything is automated, even a cyber attack. So if a cyber attack happened with deep learning model, if a case is booked, whom I should arrest? You are a police officer, there is a case saying that my deepfake video is there, some popular celebrity reported a case. Assume that that's an automatically created video, not created by any human being. Whom you have to arrest? Those kind of questions are coming up these days. Ma'am, can we go for maybe another 5 minutes? Because these two things I just want to touch upon. First thing is, we have seen two sides where AI is the protector and AI is or deep learning is the criminal. Now the thing is, what if deep learning is the victim? What kind of attacks we can do on deep learning models? There are 4 prominent possible attacks on deep learning, known as poisoning, interference, extraction, and evasion. This is a very simple attack. See what the attacker is doing is, he is inserting something into the training data such that the model don't work properly. We have just learned data is everything for deep learning or machine learning. If data itself is compromised, the model don't work properly. That's what we call poisoning. Next thing is interference. Always we get the machine learning output. That output is obviously dependent on the training data. Using this output, if you could able to extract some sensitive information in the data, that's what we call interference. I'll show you anyway. For example, we just discussed the example of facial attendance application. You are in the back end, you are an administrator. Maybe just by looking at one entry, you have identified that Mr. X is present for college today at 10 a.m. That's okay. But using that, if you could able to retrieve what kind of weather is there, what shirt he is wearing, how he is looking, and all that sensitive information, that's what we call interference. We are extracting information, sensitive information, from the output of the model. And evasion is, of course, by some means I am trying to make the model don't work properly. So I'll show you an example, you will get it better. Extraction is very simple. There is an openly available deep learning model. I copy that entire model and claim it myself, or use it in my application without proper reference to the original model or properly acknowledging the original author. It's a copyright issue basically, not just AI issue. So let us see what these individual things are. So yeah, this is what we call poisoning. So this is again from that so popular handwriting data set. So this particular thing need to be evaluated as 7. That's on a normal working. But what do I do is, I'll compromise the labeling in the data. This is a supervised learning model, we all know. We give an image and its class. Instead of placing it in class 7, I copy few images and place them in class 8. Obviously what happens? When we go for the actual implementation, when 7 is written, the model predicts it as 8. Simply what we call is poisoning. By changing the training data, we make the model work incorrectly. And this is called interference. Assume that this is also one of such facial attendance system where This is expected. When a person is present, this is what is to be stored in the database so that only his attendance is marked. Maybe from this, by maybe applying some image improvement mechanisms, you could able to identify which person it is. We may call it interference. Another simple example is, you know me, but you don't know that in which college I am present or in which college I am working. What you do is, use my image, input it to facial attendance application at different locations. Obviously what happens? In my college, you will see the attendance marked. So, you only have my photo. From that, using a deep learning model, you could able to identify where I am working. That's what we mean by interference. By using the output of a deep learning model, you are actually extracting sensitive information. And this is even more dangerous. Evasion. What is the first one? A stop sign. What is the second one? Of course, a stop sign. We can easily identify that, but unfortunately ML models can't. Why? Because they are trained using this sign only. What the attacker did here is, he simply went to the stop sign physically, he just added few markers on the stop sign. Assume that you are sitting in that one of the driverless car, which should stop on seeing this. But unfortunately, the model couldn't identify what is this and went away. These kind of things actually happen. Not an attack though. Hope you all know Tesla. They are famous for their automated driving modes. So Tesla is tested on so many patterns, they thought that it is one of the robust. There is a junction like this. If Tesla is coming in this direction, if there is a truck passing by, a big truck is passing by with a back container, usually these are painted white in US. Sky usually looks white from sufficient distance. So Tesla classified this as sky. So in front it classified road and sky. What does that mean? Road is completely free. So it went away. What happens there? They started witnessing lot of Teslas under trucks. Yes, if the training is properly done, it is okay, ma'am. But the problem there is, they trained with white colored trucks. But sky and that truck, they almost looked similar. The model couldn't identify properly. Sometimes you will be seeing lot of advertisements on the back side of trucks. That practice is not there in India, but in US it's a regular practice. And that usually involves sky colored posters. Yes, yes. Obvious, madam. Actually, there is an attack. Maybe, at least I'll share it with you. There is a Google Colab notebook which is self-explanatory. If you go through that, there is an attack where by implementing simple noise, we can eliminate the presence of pedestrians on the road. People are crossing the road, but unfortunately that machine learning model couldn't see them because of the presence of small noise. Yeah, this is what I mean by extraction. So this is, the first one is a popularly available machine learning model. Second one is simply by copying the code of it, I could able to create another model and claiming it myself. Again, as I said, it's a copyright issue, not purely this thing, machine learning based attack. So I have already shared the presentation with Kalyani madam. So in that there is a link. This thing, adversarial robustness toolbox. Those who are interested, please go through this. This has all these attacks and countermeasures, so you can understand it in a better way. I'll close it, but let me show you what is there in the Google Colab notebooks I am going to share. Oh, sorry. So these are the adversarial attacks which I am talking about. Anyway, ఇవన్నీ రన్ అయ్యలేవండి, టైం పడుతుంది. సో ఇది చూడండి, ఆల్రెడీ కంపైల్డ్ మోడల్. See, this is a panda. What is that? Also a panda. Human eyes can easily identify that. But just by introducing some noise, we are faking the model. It is identified as a gibbon. What is a gibbon? It's another class of primate, like a monkey. Let's not get into the details. Yeah. So just by introducing noise, but we can clearly see that it's still a panda for human eye. But ML fails there, or DL fails there. Yeah, this is what I am talking about. This is a model from an authentic driverless car model. So this is what is the input for which machine learning has to predict this, which is a border or segmentation of road and people walking on it, object identification. But what happened here is a simple noise is introduced. We cannot even see a noise there. Maybe at close level you can identify simple noise is there, very less noise. But see what happened, that segmentation completely failed. It is simply showing road only. What happens in a driverless car? You will be running over them. So this is a PyTorch example actually. For people who are already well versed with deep learning, there is nothing fancy or something there. Or if you don't know machine learning, simply run these cells, that's it. Create a Google Colab account and run these cells. So this is a very good example. So there are actually two types of attacks which are described in this particular notebook. One is called white box attack and another is a black box attack. White box attacks means we know the model. You have access to the internal code of the machine learning model, so that from that we learn at which noise level it fails. We introduce that noise in the data, so it fails. Another aspect is a black box attack, where we try all possible things. So this is a black box attack example. See, these are all the noises I just want to try. After introducing them, the model fails at certain levels. So white box is, you know the internals, so you can clearly see where it fails and induce that. Black box attacks is, you don't know the internals, so we try things. That's the basic difference. So there is another notebook which I am going to share, which is about how to create deepfakes. For this particular notebook only, I have given that disclaimer and all. Please learn, don't apply and post these videos in public domains. See, yeah. So this is the image, some X. I want to replace Trump's face with his face. So simply what we have to do is, first we need to identify the critical points on the face. People who are working on image processing or facial recognition, they know these things. First we'll identify the critical points on the face. Then we do something called triangulation. This helps you understand how the face is oriented. That is very much important here. Otherwise what happens is, maybe the face is looking like this and the face where the fake face might be looking like this. So which don't suit, people can easily identify. So then we create something called a fake image level 1. Then from that we create a mask. See what's happening at the second level. This is the source which you want to use. This is the original image of Trump. Now I want to add this face at this location. For that purpose, we create a comparison and create something called a mask. It's simple image segmentation only, quite easily done. Then we replace this facial part in the mask and the color is adjusted such that this gap is reduced. That black and white gap is original face versus fake face. Obviously, these two people are not in the same color, or at least the lighting and everything changes. So in the fake face, the color is also adjusted and the skin tone is adjusted. What happened now? It looks like there is a person such that, but actually it is not. So how it happens in the video is also in the same way. First thing, we need to identify the frame. In that, detect the face and align the face. Then we train the model by overlapping the faces. Then again, people who are well versed with deep learning, they might have heard of the term encoding, encoders and decoders. Again, constructors and discriminators, or generators and discriminators. Have you gone through something called GANs any of these days? GANs, generating adversarial networks. Another advancement or best thing that is happening in deep learning, which can be used for these bad things also. The thing is, the model generates an output, then something called discriminator checks it with the original. If it could identify the difference, it is retrained until there is no difference. So with human eye, you cannot identify the difference between original and fake. So we'll give a picture, then a video. Video is called a driving frame and the picture is the source. These two are overlapped and created by using something called a generation module. For example, I'll show you an output here. See, this is the source, that is the generation module. So simply, Putin is not moving, but Obama is moving. This is a picture, that is a video. Now, by overlapping this phase in that video, I am simply using a pre-trained model. This make animation and this. See what is the result. First one is the source, driving video, and the result check. Putin is also moving in the same way Obama is moving. That's how deepfakes are created. So we just need to add audio and other things. This is a very basic form of how deepfakes are created. You can create deepfakes using this method, but they are not so alluring or satisfying. Using GANs and other advanced techniques, we can improve the accuracy. See this now, this is even more this thing. Even the eyebrows, facial expressions, everything moves just like Obama. I don't have Putin's video, I have given only image input. From that it created it all on its own. It's a pre-trained model. You don't need to write any code for that. Maybe replace Putin's image with your face and obviously you can see you're uttering same words as Obama tomorrow. So maybe I'll stop with that. It's already too much delay. I'll share all these things. Already the presentation is shared with ma'am. I'll share the notebooks also right away. So thank you all.
Using deep learning, of course. There is no other way. Without deep learning, we cannot identify deepfakes with human eye.
Thank you, sir. Thank you for your valuable session. So I hope everybody got so many research challenges to work further.
sir, Sivaram Krishna sir, like 5 minutes though, I felt it's like really the CSE will be ruling the complete world because lot of things he can do, all gimmicks and everything he can do it. By only by programming, maybe the future films will be from this only. We'll write a program and there will be some exhibition of one movie or short movie can be formed. In spite of your busy schedule, you have come.